This is lesson 7.7 in the Go Math textbook. So today we're going to be talking about area and mixed numbers. So this lesson could seem a little confusing at first because now we're dealing with two mixed numbers. So usually when we deal with two mixed numbers, we're either multiplying them or we're dividing them, but just to start off, they give us some different size tiles. So they give us a 1 foot by 1 foot, a half foot by a half foot, and a quarter by a quarter. So basically it says if the floor is 2.5 feet by 3.5 feet, and she wants to use the fewest tiles possible, and she doesn't want to cut any tiles. So we have to figure out which size tiles would work the best for this equation. So first things first, which square tile should Sonia use? So if we look, we could use the 1 by 1 foot tiles, but we're working with halves here. So at some point, she will have to cut this tile in some way, shape, or form. So using the 1 foot by 1 foot tiles isn't the best option. If we use the 1/2 by 1/2 tiles, that will get us to equal measurements of these numbers since they do have halves included in them. We could use 1/4 by 1/4 tiles, but it's going to be so many different tiles. So right now, 1/2 by 1/2 is our best option, okay? Because she says that she wants to use the fewest number of tiles. So whereas 1/4 by 1/4 would work, it would create a lot more tiles as compared if we used the 1/2 by 1/2. So for the first bullet, it says, which square tile should Sonia choose? You are going to put 1/2 by 1/2 tiles. For B, it says on the grid, let each square represent the dimensions of the tile you chose. Then draw a diagram of the floor. So first things first, if we want to multiply and find the total amount of tiles we would need per se, we would have to do 2.5 times 3.5. So when we want to convert these mixed numbers to improper fractions, we multiply the bottom and add the top. So if you do this, this is 5 over 2. And then this will be times 3 times 2 is 6, and plus 1 is 7 over 2. So these are actually your dimensions right here, the numerators. So that means that our side, or one of the sides, has to measure 5, and the other one has to measure 7. So I'm just going to start here. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. Okay, so this way we have 5 by 7 here. So for C, it says how many squares cover the diagram? 5 is one of our sides, and 7 is the other one of our sides. So if we multiply 5 times 7, we're going to get 35. So that means if you count each square individually here, you should have 35 squares altogether. For this second bullet, it says, what's the area of the tile you chose? So if you do 1/2 times 1/2, you're actually going to get a fourth, or 1 over 4. So since that one square represents an area of 1/4 square foot, each of these is 1/4, 1/4, 1/4, 1/4, 1/4. We have 35 squares altogether. So now we can just multiply 35 times 1/4. So if I do that off to the side here, I would have 35 over 1, because that's our whole number, times 1 over 4. You get 35 over 4. 35 over 4 is an improper fraction, so we're going to have to divide. So, put 35 in the house, we're dividing by 4. 4 can go into 35 8 times without going over. 4 times 8 is 32. Subtract, and you have 3 left over. Take that 3, bump it up, you have 3/4. So this is our answer here. So that means over here, it's going to take up 8 and 3/4 square feet all together. And then the area written as a mixed number would just be this. So 8 and 3/4. Okay, so if we take a look at the next page, oops. Okay, so for drawing conclusions, we need to write a number sentence for the area of the floor using fractions greater than 1. So this is still working with the same information from the previous page. So we already converted them back on our first page. So we know that we have to multiply 2.5 times 3.5. So now if we were going to convert these into improper fractions, we already did that on our first page. So all we have to do is switch out those numbers. So instead of 2.5, I'm going to put 5 over 4 times my 3/2 was converted to 7 over 4. So when we multiplied, we still got 35 over 4, which is what we did at the end of that problem. We divided 35 by 4. Okay? So then that's how we end up with our answer of 8 and 3/4 from our first page. So, how many 1/4 foot by 1/4 foot tiles would we need to cover 1/2 by half? So if you think this is a half by a half, if we break it into 4, each of these is going to measure 1/4 because we're splitting it in half again, essentially. Okay, so now all you have to do for this one is 1/4 times 1/4, which would get you to 1/16. Now, if we wanted to get back to 1/4 here, we could multiply. Just going to erase this for the sake of space. We would have to multiply by 4 because if we look at our diagram here, we have 1, 2, 3, 4 pieces. So you could times this by 4, or 4 over 1, and you get 4 over 16, which also equals 1/4. So that means that we have to multiply by 4 here. So our answer is going to be 4. Number 4 we are not doing, so you can cross that one out. Okay, making connections. So use an area model to solve this equation. 1 3/5 times 2 3/4. So first thing they want us to do is rewrite each mixed number as the sum of a whole number and a fraction. So it's just saying break it down. So if we're going to do 1 3/5, it's just 1 plus 3/5. Okay, because it uses the word sum, so that means I have to have additions somewhere in here. Same thing with 2 3/4. You would do 2 plus 3/4. Okay, so now what I'm going to do is I am actually not going to do step 2 through 4, okay? Because those steps become a little confusing when you use an area model. So what I'm going to do is I'm just going to turn these fractions into, mixed numbers into improper fractions. Okay, so you multiply the bottom, add the top. 1 times 5 is 5, plus 3 is 8 over 5. For 2 and 3/4, multiply the bottom, add the top. 2 times 4 is 8, plus 3 is 11 over 4. So now I can just multiply these equations, which is great because now I just have to multiply across. So now I have 8/5 times 11 over 4. 8 times 11 is 88, and 5 times 4 is 20. So we run into that issue of now it's an improper fraction. So if we just divide 88 by 20, 20 is the same thing as counting up by twos. So 2, 4, 6, 8. My 20 can go into 88 4 times without going over. You subtract and you have 8 left over. So you bring that 8 up and you're going to put it over our original denominator of 20. Okay, so this is our answer. 8/20 can be simplified since they're both even. So I'm going to divide them both by 4. And I would actually get 2/5 as my reduced and simplest form fraction. So if you put 4 and 8/20, or you could do 4 and 2/5, it's the same answer, just one fraction is more simplified than the other. So that means that our answer here is 4 and 2/5. Or I will also put 4 and 8/20. Okay, next page is going to be the share and show page here. So, same thing. We are going to take these fractions and multiply them. So first things first, we have to convert these into improper fractions. So 1 and 2/3, 1 times 3 is 3, plus 2 is 5, so that's 5/3, times 1 and 1/3, 3 times 1 is 3, plus 1 is 4, so that's 4/3. So they're similar, but one is just a little bit bigger than the other one. So for, like we did on our first page, these are going to be our dimensions that we're going to use for our little diagram over here. So you should have 5 on one side and 4 on the other. So it doesn't really matter which way you organize them, just as long as one side is 5 and the other one is 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and then you just make the box. My lines are all crazy. Okay, so if you actually counted up each individual box in here, you're going to get 20 squares. Now, if we look at how much or what's the area of one of these squares, just like one of these, you're going to do 1/3 times 1/3, and you actually get a 9th. Okay, so that means that each box or each square in here represents 1/9. Okay, so that's what our answer is for the second bullet. And what is the area of the diagram? So if we know we have 20 squares and each square is divided by represents 1/9, we can divide 20 by 9. Okay, so now we can divide. I'm going to do it over here. 20 over 9. 9 can go into 20 twice without going over. That's 18. You would have 2 left over. Bring it up, put it over 9. There's your answer. So this is the same as 2 and 2/9. Okay? Take a look at number 2. So number 2, each box, if we just multiply the bottom, that means that each box represents 1/16. Okay? So now, let's turn these mixed numbers into improper fractions. So 4 times 1 is 4, plus 3 is 7. 4 times 1 is 4, plus 2 is 6. So here are my dimensions. 7 by 6. So it doesn't matter which side you put as which, just as long as one side is 7 and the other one is 6. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay? So this is what your diagram should look like. Kind of like a giant square. So if I just do 7 times 6, that's going to get me to 42. So now if I know I have 42 boxes altogether, I have to multiply that by my 1/16. So now my equation then turns into 42 times 1/16. Okay, so remember, anytime it's a whole number, you just put it over 1. So now you have 42 over 16. 16 can only go into 42 twice, which is 32, and you would have 10 left over. So you have 10 over 16. So your answer is 2 and 10/16, or if you wanted to simplify it, it would be 2 and 5/8. Okay. Now, question 3, same thing. We're going to turn these mixed numbers into improper fractions. So 1 times 4 is 4, plus 1 is 5, and then 1 times 2 is 2, plus 1 is 3. So 3 over 2. To make it a little easier, you can just multiply across instead of doing all this work over here. So 5 times 3 is 15. 4 times 2 is 8. Still an improper fraction, so you have to divide. 8 can only go into 15 once without going over. So when you subtract 15 minus 8, you have 7 left over. You bring that 7 up, put over your original denominator, which is 8, and you get 1 7/8. Number 4, 5, and 6 are just going to be the same thing that we just did. So turn them into improper fractions so you can multiply. 4 times 1 is 4, plus 3 is 7. 2 times 2 is 4, plus 1 is 5, or 2. Multiply across, you get 35 over 8. Divide. 8 can go into 35 4 times without going over, which is 32. And you have 3 left over. Bring it up, put it over your original denominator of 8. So your answer is 4 3/8. 5, same thing, turn them into improper fractions. 8 times 1 is 8, plus 3 is 11. And we actually just converted this fraction right over here. So we have 5 over 2. Multiply across, you get 55 over 16. Divide. 16 can go into 55 three times, which is 48. Subtract, and you would have 7 left over. Bring that 7 up and put it over 16. Okay, so 3 and 7/16 is your answer. Okay, number 6. 1 times 9 is 9, plus 1 is 10, so 10 over 9 times 3 times 1 is 3, plus 2 is 5 over 3. Multiply across, 10 times 5 is 50, 9 times 3 is 27. Divide. So 27 can only go into 50 once, because 27 times 2 is actually 54. So you just put 27 there. When you subtract, you have 23 left over. So bring that 23 up. Put it over your original denominator of 27. So 1 and 23 over 27 is your answer. We're not doing number 7, so cross that guy out. Okay, and the last page that looks like this is going to be your homework tonight. Okay, so think about, if you look at this problem, think about how many boxes you have here and how many boxes you have here. So you have 3 here, and you have 1, 2, 3, 4, 5, 6, 7 on the top. Okay, so if you have 3 and 7, all you have to do is write a problem that would be equivalent or applicable to those numbers. So think of, they give you the topic, which is a garden. So just something as simple as Terrence is designing a garden. He wants the side lengths to be 3 feet, and he wants the top and bottom dimensions to be 7 feet. How much total area does it take up? Obviously, 3 times 7 equals 21. So that's your area. Okay? And then down here, it's just asking you to describe the dimensions that you decided to use, which was 3 and 7. So you're just going to say, what does 3 represent and what does 7 represent? Okay? And that is all.